This video is going to cover false negative fraction and false positive fraction, and it's just kind of building on my video on sensitivity and specificity. So if you don't know about that, you should probably watch that first, but I am just going to briefly go over it again. So sensitivity is the proportion of the diseased people that are truly disease positive that the test called positive. So this notation here is A, B, C, D. So cell A over cell A plus C. And in this example, it would come out to 93% sensitivity. So it's really good at finding those who are truly disease positive. Specificity, on the other hand, is the number of true negatives, so the number that the test called negative that are truly negative over all of the people who are truly disease negative. So D over B plus D. And in this case, it comes out to 70% specificity. So the test isn't great at correctly identifying people that are disease negative. They only correctly identified 70% of this total group that are disease negative. These 26 plus 62, we were only able to get 70% of them right. So the false negative fraction is the rate at which the test is producing false negatives, and that's just 1 minus sensitivity. An easy way to remember that is n negative and n for sensitivity. And yeah, so in this case it would be 1 minus 0.93 or 0.07. So the test is only producing false negatives at a rate of 7%, so it's doing a pretty good job. For specificity, the false positive fraction, it is 1 minus specificity, and you can remember that because positive and SP, specificity. So in this case, it's 1 minus 0.7 or 0.3. So the false positive fraction is 30%, meaning it's producing false positives at a rate of 30%, which is pretty bad. But I guess it kind of depends on the situation. With a false negative fraction of 7%, the test isn't producing that many false negatives. And that is because it has a high sensitivity, and its false positive fraction is 30%, and this means that it is producing a lot of false positives, and that's because it doesn't have great specificity.